on here, and I always forget that there is some other stuff on here. So we want to move on to something called aromatic compounds. And I don't know if you remember information about aromatics. We talked about this on the very first day of organic chemistry. And we drew a picture related to aromatic compounds. Do you remember drawing that hexagon? And the hexagon had 3 double bonds in it?
Oh, yeah.
Yeah.
Yeah, like this.
So, this is a model of what, it's a chemical called benzene. Now, benzene is an additive that we add to gasoline. It's an anti-knock additive, and basically what it means is that this allows this chemical is really stable. It allows the gasoline to basically burn slower or at a more predictable rate. Inside your engine, I don't know if people have, I don't know if people really know what happens inside an internal combustion engine or a 4-stroke engine. Oh man, I don't know. What am I eating?
Maybe you can do something with that.
Oh my gosh, we just figured it out. Tesla, step aside.
Tesla, step aside. We have something to do with it.
Electricity,
Yeah.
Salt.
Okay. So this is
very blurry.
Yeah, I know it's pretty blurry. I get that. I understand that. So what's going to happen here is that inside your engine, the way your engine works is that there's going to be a crankshaft, and the crankshaft is attached to a piston. Now, the crankshaft turns by having something force the piston down. That's the idea. You have a mini controlled explosion inside your car. In every single inside every single cylinder of your engine. So, for example, I drive a very, very not powerful 4-cylinder engine. Yeah, it's the most base model Honda Civic you could possibly imagine. It's a 1.7 liter single overhead cam engine. Yeah, it's about 102 horsepower, so it's pretty powerful. Yeah. So what's happening is that inside this combustion chamber, you're going to inject fuel into here. Now, fuel doesn't burn all by itself. What does fuel need to be mixed with in order to burn? Oxygen, and we get oxygen from our air. So you have to have an air intake. The air has to be able to flow into the combustion mixture, and you have to be able to inject. Some fuel into there as well. Then there's going to be a spark plug in here. The spark plug's job is to ignite the fuel-oxygen mixture, and then when the explosion has happened, then that exhaust can leave the combustion mixture, or the combustion chamber. So what happens is in the operation of this, so the exhaust leaves, right? Basic components, yeah. So in the first stroke, we put in some fuel, it blows up, okay? We compress it. Oh man, this is way slower than I thought it was going to be.
And then it goes boom.
Yeah, we inject some fuel, it goes boom. So it pushes the piston down, which turns the crankshaft. And then we push out the exhaust. Now the problem with this is, and then when it comes down, it'll pull in more air and fuel mixture. It'll compress it, it'll blow up, it'll push it out, blah, 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 blah. So this process happens over and over and over again. The problem is, when that complosion, oh my god, when that compression and explosion happen, off, or if the explosion happens too fast. If the explosion happens too fast, that's what we call knocking in your engine. Has anybody ever heard a car that was, you know what I mean?
That's my name.
Yeah.
That does that.
What?
Jordy owns a vehicle that
Does it?
That car sounds great. That also, he doesn't put oil in it. So that can-
Oh.
Yes, I do.
Well, this is, I didn't know this was going to turn into an indictment of Jordy's mechanical abilities, but that's fine. So what happens is, benzene's a stable molecule, but under certain conditions it can react. And so what we do is we add some of these fuel additives to make that explosion just last a little bit longer. Because when it lasts a little bit longer, you get the force of that explosion spreading out over a little bit more time, and you get a smoother stroke inside your cylinder. And so that provides you more power, and it also doesn't start to break apart parts of your piston and parts of your cylinder and your rings and things like that. So anyways, that's just a little bit of a background about why benzene is an important molecule. Benzene is also really carcinogenic. Do you know what a carcinogen is? Cancer causing. So benzene is an extremely carcinogenic molecule, and so, okay, good and bad, all right. Aromatic compounds are compounds that include a benzene, sometimes we call it a phenyl ring in the compound somewhere. They are named aromatic because the first few compounds with benzene were quite smelly. The first few compounds with benzene in them, they had a strong scent to them, so we called them aromatic. Not all benzene molecules are aromatic, are smelly, but whatever. Benzene is a very stable molecule and doesn't behave like an unsaturated compound. That's interesting. Let's look at benzene. Benzene is a 6-carbon ring. But benzene it's got 3 double bonds inside of it. So they're alternating double bonds. Now that's very interesting. Would you call this molecule saturated or unsaturated? You would call this unsaturated, but it behaves like it's saturated, or it doesn't behave like it's unsaturated. So we'll talk about why that is a little bit later, and it has to do with how stable it is. How many hydrogens are on this ring? There's 6 carbons, but how many hydrogens? How many hydrogens on this carbon? One. How many on that one? One. How many on this one? One. So what's the formula for it? C6H6. Good. Now that's not the only way we can draw it. Let's do a line diagram for this molecule. So we could just draw a hexagon, and we could do the 3 double bonds inside of it. Sure, no problem. Or there was a second way of drawing it.
Circle.
Yeah, and I want to make sure you understand why that is. There is no evidence, and this is actually kind of important, so I would like you to listen up. There's no evidence to suggest that these 2 carbons are double bonded with each other, and these 2 carbons are single bonded with each other. There's no evidence to suggest that. Every time we look at an aromatic compound or an aromatic ring, it's almost like some of the time this behaves like a double bond, but some of the time it behaves like a single bond. Some of the time this behaves like a single bond, some of the time it behaves like a double bond. Do you kind of see where I'm going with this? So there's no way to distinguish between this combination of double bonds and this combination of double bonds. It's kind of half double bond and half single bond all the time. So in order to represent that, what we will do is we'll just draw a circle in the middle. And this denotes that we don't really know if these are double bonds or single bonds. In our model, we show them as double bonds, but in real life, they're not double or single bonds. They're like a mixture of the two. So it's important that you understand that this is the same thing as that, it's the same thing as that, it's the same thing as that. They're all the exact same thing. Perfect. Are we good? Are we kind of happy with that? All right. Naming aromatic compounds is identical to other compounds, except, what was the name of this ringed structure again? Nope. Benzene. The name of this compound is benzene, right? So instead of cyclohexene or cyclohexane or something like that, okay, how many methyl groups are on here? 2. And we should probably start numbering at one of the methyl groups, right? So this is going to be 1, 2, 3. So how would we write this normally? 1,3 dimethyl benzene. Sometimes in chemistry textbooks you'll see this written as orthobenzene, but you'll learn about classical naming systems for these things in college or university, so don't worry about it. 1,3 dimethyl benzene. Perfect. What about this one? Notice this is the ring with the circle in it. This is the ring with the 3 double bonds. What's the difference between them? Nothing. No difference. They're the exact same thing, right? So how many branches do we have on here? We got 3 branches. And do you want to start numbering, I don't know, where? Where do you want to start numbering?
The big boy.
The longest branch.
On the longest branch? Do you want to start numbering there because it's the longest branch?
Yes.
Or do you want to start numbering there because of something else? No. Remember, this is a double bond, but that's a double bond, but that's a double bond, and also there's a double bond here, and here, and here, right? There's double bonds everywhere. So we can't use the double bond to be able to help us. Alicia. Good. We're going to get the lowest total sum of branch numbers here, right? If we name this a 1, where are we going to start going? Should we go clockwise or counterclockwise? 1, 2, 3, 4. If I add up a 1, 2, and a 4, I get 7. If you add up any other combination of numbers, you're going to get greater than 7. For example, over here, 1, 2, 3, 4. A 1, 3, and a 4 is 8, right? If I started here, I have to go all the way around one way or the other. So, anyways, so it's a 1, 2, and a 4. What's this thing going to end in? Benzene. And what are the types of branches do I have on here?
1 tetra. 1. Oh yeah, 1 butane.
So okay, so I've got a couple different methyl groups, and I've got how big is this chain here?
4.
That's 4. So it's a butyl group, right? A butyl, like methyl, ethyl, propyl, butyl, right? So this is going to be, that's a 1 butyl. And then this is a 2 methyl and a 4 methyl. So this is going to be 2, 4 dimethyl, right? So what am I going to put first? Should I put the butyl or the dimethyl? Butyl. I should put the butyl first, right? So I'll put the butyl first. Whoa. I'll put the butyl first, and then I'll put the 2,4-dimethyl second, and I'll put a gap in between them, and we're good to go. 1 butyl, 2,4-dimethyl benzene. Okay, so far, other than the name benzene, is this any different from naming cyclic compounds? No. Okay, so it's just benzene that you have to get used to, right? I would like you to draw a couple compounds for me. I'm going to walk around. Let me know if you have any questions. Yeah. Yeah, but you have to. The branches are always off of the parent chain. This is based in parent ring. We want to count all of the carbons outside of that circle, right? So 1, 2, 3. Yeah, because that's part of the parent chain or the parent ring. I like to draw my hexagon first. I'm looking a little bit the other way. Oh. That's a die. You're never going to see a die.
Baby photo of thick.
No. Okay, so you have I agree that a 3 That's awesome. Not bad. But how big is your parent? 40. That's the only thing. That's the only thing. Yeah. So you have a butyl group. So 1, 2, 3, 4. And then you've got ethyl groups on 2 and 3. Sure? Okay with that? And then 1, 2, 4, 5 tetramethylbenzene. Okay, no problem. So 1, 2, 3, 4, 5. Okay? Yeah? No problem. Ah, man.
What?
I don't know. I add this slide every time, but okay. I want to be very clear. I will never test you on this slide personally. I'm going to teach you because I'm unsure of whether or not this is actually in our curriculum, and I need to talk to some other people. I've never once seen it on a diploma exam. I'm going to mention it, and then we're not going to practice it ever again, okay? So, usually, so far we've been dealing with benzene as a parent ring, but what we can do is we can actually have benzene as like a branch off of a parent chain. Now, when we do that, when the benzene ring is a branch off of the parent chain, we call it a phenyl ring. And I struggle to teach you this because I honestly feel like it's just not worth you knowing it. But we're just going to talk about it really quick. So we're going to call this a phenyl group. So for example, what's the longest parent chain here? So we got to look at this as being our parent chain. How many carbons there? So it's going to end in pentane. And where is my phenyl group attached to? 2. So we're going to call it 2 phenylpentane. Is that okay?
Yeah.
It's just, I've never seen it before, and I just think it's extra information that I don't think you should really care about. This one, I would like you to try and name this one for me, please.
Is there ever a case where there's two phenols?
Yeah, you could get diphenyl or triphenyl. Yeah, it's the same as any other branch, right?
Oh, yeah.
It's a non.
Yeah.
I swear.
Is that octane?
Yeah, that's what I was confused about. I'm like, wait a second. Something's not right here.
It's always counting. It's counting that I'm bad at. I think that's my problem. And spelling and drawing. So basically, my kindergarten and grades 1 through 2 teachers really failed me. Actually, I think I failed them. But.
I don't totally understand this because why would it?
Okay, well, what's your long term change? Don't ask me. Plain white guys from 60.
But then this one's phenylpentene. This next one is octane.
Yeah, but it's 3 phenol.
So why is
The
it?
phenol group is on 3.
Oh, okay. No, I'm looking at the last one.
Yeah.
Never mind. Thank you.
Okay. Yeah, I would like you to try this question for me, please.
Whoa, the compound.
Do you remember what the word isomer means? Same chemical formula, different structure. Right?
Where's his? Which one is his? Sir? Sir, which one is his? Where's the source book? Where's the...
Or hers.
Oh,
Where's theirs?
shoot.
Student drawing.
Yeah.
Oh, really?
Wow, that's embarrassing.
But if it says compound is contained.
Yeah, that's.
They do, but I think it's like 8 in a chain.
I need a. Well, I mean, it's one.
5. No, if it contains it, I think it's based. I think this question is based on this.
That's the original structure the student drew. So you have the question in front of you, but that's the original structure that the student drew.
Oh.
So I want you to figure out how many of those are isomers of this. Again, what is the definition of an isomer? The same, not the same number of carbons, the exact same chemical formula. The same, if this one has 8 carbons, the other one has to have 8 carbons. If this one has 12 oxygens, the other one has to have 12 oxygens. Now there's no oxygens, but hopefully you know what I mean. I'm gonna give you 2 minutes to figure this out, and then we're gonna talk about it together. Let me know in 10 or 20 seconds if you have literally no idea what this question is asking.
It's not my thing, it's 2 carbons. It has 1
I know, but that's, it says,
Yeah, but
it says the compounds above that are isomers in the structural diagram of the student. So that's what the student did. No. You have to go, which one of these, how many of these are isomers of that? I know it's tough, right?
Yeah,
I would
so 6
suggest.
one would have just been.
I would suggest, right? Yeah, but how many carbons are in there? Count up all the carbons. Yes, yes. Whoa.
How many is
But even like white tetrahedral, that's the one I counted. I'm just
Maybe redraw this and count them up. Aiden, how many hydrogens are right here? 3. Okay, how about here on this carbon? 1. Because there's two bonds going into it, right? So there's 2 extra bonds. How many there? 2. How many there? 1. And then 2, 2, 3. So if we added all of those up, we could figure out what the chemical formula is.
I got
Only 1,
5, 6, 7, 9, 10,
and I wanna. There's a 20-second way of answering this question. Oh, really? There's a way of answering this question in literally 20 seconds.
That's what I did.
Is that what you did?
Yeah.
Did you figure out what we did yesterday? That idea of how many hydrogens are missing?
Yeah.
Yeah.
I know it's
I just did E's and cyclos.
There you go. They're the same thing, aren't they?
Yeah.
Yeah.
Maybe I'll maybe.
Oh, is this legal? Like, a line diagram as well?
Yeah.
I did one
Is 2 in there?
I didn't know if it was 2.
what they're doing is they're just
Okay.
they're not showing you all the hydrogens. So they're trying to mislead you because some people will forget that there are hydrogens here, right?
Sleep good.
So
But I think they have the privilege to do that, right?
yeah, they have the privilege to do that.
Wow.
Until 10. And then I gotta be at work again tomorrow. And then I work till 10 again. And then the next day, I'm at 10 after work.
There's 3 hydrogens
And then I'm
here.
off until Tuesday. And then I work
On
again.
this carbon,
Yeah.
that one.
Yeah. After Sunday.
9.
After Sunday, you know, I get the day off. And then I'm off for 6 days. And then I work the 23rd.
Okay, are you ready for the solution? What? This is a 20-second solution. Okay, let's think about this for a second. How many carbons are here? 8. So C8, and it should be H18, right? But because there's a ring, how many hydrogens have we lost?
2.
2. So it's actually 16. So you're looking for a structure that has either one ring or one double bond. Do we remember that from yesterday? A double bond has the same effect as a ring. They both lose 2 hydrogens.
Yeah.
So when I look at this, right, there's one ring in here. So either an isomer could have either one ring or one double bond. Let's look at this. Does this have a ring or a double bond? No. Does this have a ring or a double bond?
Yes.
1. Does this have a ring or a double bond?
Yes.
Ene. It has one double bond. Yes. Does this have a ring or a double bond?
No.
No. Does this have a ring or a double bond?
Yes.
Yes. Does this have a ring or a double bond?
Yes.
Propyl cyclopropane. Does this have a ring or one double bond? No,
Yes.
this has a ring and it has 3 double bonds, right? So it's out.
Oopsies.
Way too many hydrogens.
Does it kind of make sense? That logic? Now, that's the really quick way of going about it. That's the really quick way of going about it. The other way of going about it is by physically drawing out every single one of these names, right? Oct3 enes, you go to 1, 2, 3, 4, 5, 6, 7, 8, and you gotta go Oct3 ene. And then you gotta count up all the hydrogens. Man,
Yes.
that's such a pain in the butt. But as long as you understand, oct means C8, and then ene means we've lost 2 hydrogens. So instead of 18, we're at 16 now, right? It's the same chemical formula as the one before. Does that kind of make sense? Okay. Let me know if you have any additional questions about that. I got another. This question you can't totally answer. I will give you a hint. The carboxylic acid is number 3. But everything else, I think you should be able to logic and reason your way out of this one.
Yeah.
Okay, so saturated is like the maximum capacity of what the bond or of what the molecule can have. Saturated.
Yes.
So,
For the wrong line, it's combined usually. This is so confusing.
the only time we had the
usually
let's do white papers.
another.
And the thing is, you even get like kind of
Okay, so for example, unsaturated and aliphatic. What is unsaturated? What?
yeah, but I mean double prime has like
Okay, so
double prime.
unsaturated
It has a double prime or a triple prime.
is that's not at natural capacity of the
Yeah, but okay, but remember, unsaturated is carbon-carbon double or triple.
No, you're just looking for unsaturated. Aliphatic or unsaturated.
I was about to say she said that she has trust issues.
I know. Yeah, so that's out, okay? That we already used that number, right? We already used that number, so that's out anyway. Yeah, but why? Yeah. It's hard to see, but there's a double bond. Okay, but that, but remember, these act as if they're saturated, right?
And then we can never
Just for them.
Yeah, what do you mean by carbon?
Carbon,
Except
a carbon. Things that are unsaturated have carbon.
I love how people obviously really knew into the thing.
Yeah, I know that.
Yeah.
Maybe they did something else. Maybe I wasn't really good.
Yeah, more stories. It'll come up, trust me, it'll come up. Okay. Let's think about this for a second. Aromatic. How many of these compounds are aromatic? Two, actually. Right? Okay. So the aromatic one could be 1 or 2. All right, that's fine. We'll move on. We've already dealt with 3, so don't worry about that. The next one, what's the next one say? Unsaturated. What does that mean? What does that word mean, unsaturated? Yeah, it means alkene or alkyne. That's what it means. Do you see anywhere in here an alkene or an alkyne?
I see an alkene.
I for sure see an alkene, right? That's a carbon-carbon double bond. So 4 is right there. Okay, so it's gone. Then the halogenating hydrocarbon. Halogenated hydrocarbon. What the hell is a halogen?
Halogen.
What the hell is a halogen?
Number 2.
Over there.
Row
Number 17.
It's not row, it's column or group, period.
Okay, thank you.
Row, period, same thing. Column, group, same thing. Okay, or family. So family number 17, right?
Yes.
Yeah. Bruh. So this is halogenated. Do you agree? Yes. So 2 is out. We can't use 2 anymore.
Whoa.
So if we can't use 2 anymore,
What's whoa? That's so
1, 3, 4.
No, magical.
Is that okay?
It's magical. Okay, it's magical.